the mining of non-metallic minerals is remining is non-metallic minerals. The most famous of them oil, phosphorates, natural gas, granose salt, and oil production in Kazakhstan is the most important sector of all mineral mining production. For today, the Republic's proven oil reserves amount 40 million barrels or 6.5 million tons of oil. The projected oil reserves for the fields located in Kazakh sector of Caspian Sea alone amount for 124.3 billion barrels or 17 million tons. The Republic produces about 25 million tons of oil every day. Thanks to this.
Hello. Are you still at the first slide, right?
Oh, okay. So machine learning is at the heart of many innovative artificial intelligence technologies. Programs that are developed using machine learning can predict when equipment will fail, as well as customer behavior, on the basis of which logical and analytical decisions are made. So machine learning does not imply manual input of decision-making rules into the algorithm. They are determined automatically by the system based on empirical data. Learning is a process of introduction empirical data into an algorithm for further forecasting based on this data. Machine learning in mining and mineral mining have advantages and disadvantages. Advantages are processing large amount of data, fast data transfer, analysis-based accuracy, providing the same type of forecasts, and the ability to identify patterns. Disadvantages are it takes a certain amount of time to process the data, possibility of errors, and the need to choose an algorithm for correcting errors. The use of data must be good quality and impartial. And last of disadvantages is lack of data. So application area in mineral mining. One of the things is minimizing production downtime. Machine learning can help prevent downtime. To carry out this process, data is collected from sensors located on the equipment. Then those indicators that lead to failures are analyzed. In the future, such information will make it possible to predict in which case downtime may occur. For example, using the example of oil and gas equipment manufacturer General Electric Oil and Gas, we can look at the process of preventing downtime. The company uses the industrial Internet of Things and machine learning. First, the platform collects data on the state of oil production, then a schedule of diagnostics checks is drawn up. These actions lead to the fact that breakdowns are detected long before they occur. For example, the platform helped Kuwait Oil Company increase gas production by 5%, and Malaysia Oil Company Petronas reduce maintenance costs by 10%. Next example is machine learning predictive and accident prevention system for offshore oil and gas wells and pumping units has enabled British Petroleum to reduce its total operation cost by $2 million. This is due to the fact that the downtime before repairs has been reduced due to the improved distribution to a force of the repair crews. So, next, creation of a production management system. Machine learning allows you to manage your entire production, reduce the number of defective parts, optimizes individual steps, making them then significantly significantly less time, reduce costs by using fewer materials, monitors the condition of the equipment, records the efficiency and workload, and automates individual stage of production. Identifying security threats. Machine learning makes manufacturing safe. It's necessary to identify changes in the operation of equipment in advance and notify in time of a possible disaster. Consider the example of the energy company Shell. It uses machine learning to automatically identify potential threats and alert employees. This allows you can react in advance to the problem at its initial stage. Shell uses machine learning to optimize production and mining minerals. Next things is exploration of new mineral deposits. Finding new deposits is the biggest challenge facing the mineral mining industry. Machine learning can significantly speed up the process of discovering new deposits. Models are built based on existing data about past mineral deposits. These models can predict with high accuracy where the mineral deposits of gas or something else. So the hugest company of mining minerals is the Russian company, is Gazprom. And Gazprom is running the Digital Core project. This is a digital laboratory where reservoir analysis takes place using machine learning technologies. A sample is taken and the algorithm begin to simulate conditions. The resulting digital twin of the deposit makes it possible to understand how much mineral reserves are in the deposit. Individual development of the futures of the work begins. As a result, the extraction of minerals increases by 1.52 times. So next, geologists in their practice are faced with different types of machine learning. This can be the compilation of simple linear regressions, the use of geostatistical methods to resource estimation. In the second case, the input data as spatial coordinates, as the output data are the content of the available component. Data for training is selected from the sampling base with reference to the site. Back to again, machine learning has more advantages and disadvantages. I just forgot to show another slide and previous slide. Advantages are allows you to identify the necessary geological exploration objects in conditions when there is too much information, recognize the geological area in which minerals are located, reveals how hard or is, whether the meets the declared characteristics, identifies samples of glacial deposits and the presence of gold particles from photographs. Disadvantages are the algorithm does not always reveal the patterns according to which the breed can change. The algorithm must be programmed for a specific narrowly formatted task, possibility of false correlations, difficulty of work, the need to constantly improve qualifications. At the moment, it's very difficult to find geological exploration information standardized for the use of machine learning. To popularize this technology, data must be collected and stored efficiently. To achieve these results, geologists will have to learn how to apply machine learning methods. Machine learning methods must be tailored to the specifics of geological disciplines. These disciplines are by the presence complex temporal and spatial relationships. Therefore, you need a clear understanding of required data to solve a specific problem. There should be an algorithm for organizing data processing, their interpretation. Only a highly qualified specialist can handle this. So if assumptions are based on the wrong models, the consequences can be dire. Consider an example of an algorithm for recognizing deposits of the Cordillera from multispectral satellite images. The task of the algorithm is to identify those patterns by which the rocks change. If the algorithm is programmed to work with photographs from already developed fields, then the connection will be established with all the large open pits and are the photographs. Such objects do not carry an economic significance. In mineral mining, machine learning is increasingly being used. Their effectiveness is especially evident when it's necessary to solve the same problem as well as problems with a large amount of data. Machine learning algorithms are ideal tools to solving various tasks and problems. It should be noted that the management of such algorithms requires high qualifications and experience. Machine learning is an innovation that's invaluable in the mining industry. It allows to significantly reduce production costs and improve the performance of the economy. Machine learning is a paramount of importance to mining and geology in perspective. So I just finished my presentation.